The introductory video in this At-Risk XDK series illustrated a simple program for automating several of At-Risk's most important features. Although the code for the first program was explained in some detail, it was pasted into a module, so you didn't actually watch it being written. In the present video, you can watch this process, and you will see how a very powerful feature of the Visual Basic Editor, Intellisense, helps you program quickly and correctly. Specifically, Intellisense helps you choose the appropriate properties and methods for objects. It indicates required and optional arguments for methods, and it lists built-in constants for you to choose from. Once you get used to Intellisense, either for At-Risk or for Excel itself, you will be hooked. It is really good. Here is the same model that was used in the introductory video. Recall that its single output is the NPV. Here is the Visual Basic Editor. Just to remind you, the first thing to do is to set references to RISC XLA and the At-Risk object library. Next, you add a module and start writing your code. I will enter the same code as in the introductory video, but for simplicity I will omit the comments. I will begin with the subline. Note that parentheses are required next to the subroutine's name. These are for the arguments of the subroutine. Even if the subroutine has no arguments, the parentheses are required. As soon as I type the first line and press enter, the last end subline is added automatically. Next, I will tab to indent, and I will enter the first with line. Note that indenting is not absolutely required, but it is highly recommended for making your code easier to read. As soon as I type RISC and a period, I get Intellisense to indicate what can go next. I will choose simulation. Then when I type another period, I get another list. This time I will choose settings. This is the with line, and to remember that an end with line is required, I will type it next. Inside this block, I will again indent. Then when I type a period, Intellisense lists the possible settings. I will choose the number of simulations and the number of iterations and give them values. Next, I will choose the Automatic Results Display property and type an equal sign. Intellisense indicates that the possible values are from an enumeration, and I can choose the one I want. I don't even have to remember the spelling. This completes the settings. Next, I will add a line to start, that is to run the simulation. Intellisense helps me again. Note that I added a couple of blank lines. VBA ignores blank lines, so it is good practice to separate sections of your program with blank lines for readability. Next, I will enter a with line for the simulation results. Intellisense again lets me go from RISC to simulation to results. Then I will enter the ending with line so that I don't forget it. Inside this with block, I will indent and enter a with block for summary statistics. Intellisense indicates that there is a method called getSimulated_output, and it shows the arguments of this method. The first argument is a reference to the output. One way to reference this output is with a range name, NPV, which I created in the worksheet. Note that some methods have optional arguments, in this case the simulation index, in case there are multiple simulations. Optional arguments are shown inside square brackets. If you omit them, the default values are used. In this case, the simulation index 1 will be used, which is the only simulation for this model. Inside this with block, I will write several summary statistics to specific cells. Note that the left side of each of these lines uses the Excel object model to store a summary statistic as the value of a particular cell. Here is the statistic. I will pick off the mean. Just as another example, I'll do the standard deviation. And a percentile or two. This uses the P to X function. And it requires an argument, the percentage you want. In this case, 5%. Or the 95th. Finally, I will use another with block to get a graph of NPV and send an image of it to the active sheet. Remember that we're still inside the outer with block on the results of the simulation, and these results include several types of graphs. There are several types of graphs. I will choose a simple method, graph distribution. It lists several arguments, but the only one that's necessary is a reference to an output or input. I will again reference the NPV output. The with line creates an implicit reference to a risk graph object. So inside the with block, Intellisense lists all properties and methods of a risk graph object. In this case, I will use the image to worksheet method and list the arguments it requires. The active sheet. The second argument is the type of image. And Intellisense shows me the possible types from another enumeration. I will choose the BMP type. The last four arguments, left, top, width, and height, determine the position and size of the graph, and you can experiment with their values. This completes the program. Obviously, there are always chances for making mistakes, so you would now test your program to make sure it is working correctly. But hopefully this video has convinced you that you can write an at-risk program fairly quickly by using the powerful Intellisense to guide you along the way.